Good morning, everyone, and thank you for taking the time to join us in today's webinar. My name is Abdel Jabbar. I am one of the Grandstream support engineers for North America here in Boston. I am glad to host today's Grandstream Tech Talk. Just for those of you who don't know what Tech Talk is, it's a new webinar series in which we provide tutorials on the most popular subjects chosen by you. So every quarter, Grandstream sends a survey to our customers to choose a topic that they would like us to include in the Grandstream Tech Talk. So based on the last survey we did, these are the top 5 chosen topics. So the first one is VoIP deployment, and we're going to talk especially about the network best practices. Then we're going to talk about the SIP settings on the UCM and the GXP phones. We're not going to go through all the SIP settings, but if you feel that there is a SIP setting that you would like to know about and see how you can configure it, please go ahead and submit the question in the Q&A section, so at the end we can do a quick live demo. Then we're going to demo how you can use WebRTC on the UCM 62 and 6500, and we're going to talk about the major enhancements included in the firmware version of the UCM 1.0.19.21, and we're going to wrap up the presentation with some troubleshooting tips and how you can use the troubleshooting tools available on the UCM as well as the GXP phones. So just a little housekeeping before we get started. This session will be recorded, and I will send you the link for the recording later today. As you might know, there is the Q&A section and there is the chat section in the IP video talk profile. So for questions related to the topic of today, please use the Q&A section to type your queries, and we will have some time towards the end of this webinar to go over them. All right, let's get started. Excuse me. So the first item in our list today is VLANs. In this slide, I will describe VLANs and provide some guidelines and configuration examples. And just generally speaking, before we get started and start talking about VLANs, I'm just going to give you like, why do we need VLANs? And what do they do? So the main function of VLANs is that it allows the logical segmentation of your network by function or application, regardless of the physical locations of the users. And this brings us to the question, why would we need to segment the network? For voice traffic, there are several benefits in separating the data and voice. And one of them is that VLANs can find the broadcast domain of both the voice VLAN and the data VLAN. For example, if you have an application on the data network that floods broadcast and multicast packets, the switch and the router will prevent this traffic from reaching devices on the voice VLAN, and this significantly reduces unwanted traffic and also I would say saves the processing resources of the devices on the voice VLAN. Another benefit of using VLANs is that voice traffic can be marked with a QoS to prioritize it over the data VLAN or the data traffic. And without QoS, if there is a congestion, the voice and data traffic would be competing for bandwidth on the network. And this would create issues on the voice VLAN like jitter and delay and choppiness in the audio. In the next slide, I will talk more about QoS and how to configure it. But before we do that, let's explain the different ways VLANs can be set up on the Grandstream devices. So I will use the diagram in the slide as an example to explain the VLAN configuration modes. And the most common one is assigning a switch port to a specific VLAN And this is referred to as a port VLAN based membership. In other words, you just go to the configuration page of the switch, and then you assign a VLAN to the interface of the switch. In our example, the FTP server, for instance, can be configured with a static access membership mode with the switch port that belongs to one VLAN and is manually assigned to that specific VLAN in the data VLAN. The same thing applies to the UCM in the diagram. You can go to the UCM and you can tag the traffic. You can tag the UCM with the VLAN ID, or you can simply go to the switch port on the switch and then manually assign the interface to the voice VLAN. This way, when the switch connects to the interface, it will automatically be assigned an IP address from the voice VLAN. In case there are more devices in the network than the available ports on the switch, one switch port can be assigned to two VLANs. For instance, the switch port used by the IP phone can be assigned voice VLAN and data VLAN. And as you might know, most IP phones come with dual Ethernet port, the LAN port and the PC port. Usually you connect the LAN port directly to the switch port, and the computer you connect it to the PC port on the IP phone. And one thing that to keep in mind is that the link between the switch port and the IP phone, in case we use this implementation, should be in a trunk mode, because the IP phone is going to send the 802.1q, which means the frame is going to include the VLAN tag, and it's going to add a new header for the 802.1q tagging. And the link between the PC port and the computer will be in access mode. So when using that setup, always ensure that the voice VLAN from the IP phone is tagged, which means you need to go to the phone and include the tag, or you can do it from the switch port of the switch. And the traffic from the computer forwarded by the IP phone is untagged. Or the IP phones now support an option where you can send both traffic as tags. And I'm going to show you this when we go through the web interface of the IP phones. In case you have an unmanaged switch or hub, or you're not comfortable with VLAN configuration on an enterprise level switch, you can simply create the VLANs on the router. And then you go to the web interface of the IP phones and configure the phones manually with VLAN tags. And that's what I'm going to show you later. And this method is referred to as tag-based VLAN membership. So in a few moments, I will go to the web UI of the phone to show you how you can set the VLANs. But before we do that, I just want to talk a little bit about the QoS, because they are related. So as I mentioned earlier, one of the benefits of using VLANs is that it makes it easier to configure QoS at the layer 3 and also at the layer 2 to prioritize delay sensitive traffic. And I mean by that voice traffic, of course. So what is QoS? And a lot of people ask, why do we need to configure it on the switch or the router? Well, as you know, when there is congestion and delay in the network, some packets will be dropped. And I'm going to give you this example. If a user A is playing online games at work and user B is engaged in an important conference call, and the network for some reason got congested, the default outcome is that the traffic flow of both user A and user B will be dropped, despite the fact that the conference call is more important, because the switch or the router has no mechanism of detecting which traffic is more important unless it is explicitly configured on the router and the switch to prioritize conference traffic over gaming traffic. And that's where QoS comes handy. So to avoid random packet loss, QoS can be configured to prioritize the traffic that is delay sensitive. In our example, it's the conference call traffic. In other words, you can choose specific network traffic and prioritize it based on importance or based on the degree of how or based on the level of delay sensitive that this application can support. So doing so will make the network performance more predictable and when bandwidth utilization more effective, because you would know that the switch or the router will always prioritize the delay sensitive traffic from the video conferencing devices or the voice devices like the IP phones or the IP PBX. And QoS is not actually one feature that you enable on the devices to enhance the network performance. It's actually collection, I would say collection of many QoS mechanisms that work together to improve your traffic flow. So today I'm going to talk about the basic tools and features and explain exactly how they work. The two mechanisms that are supported on the Grandstream devices for QoS are layer 2 CoS or class of service and layer 3 diff serve. First, let's start with the diff serve and explain what it means and what it does. Diff serve or differentiated services uses the DSCP market. It's a protocol. It's called DSCP. It's used to mark and classify certain types of traffic with a standard value that determines the priority of the traffic. And I believe DSCP, they use 21 values in total. I can probably show you this later. But for today's presentation, since we're only talking about VoIP, there are only 3 values that I'm going to explain later. And one more thing is that DSCP works at the layer 3, usually at the network boundary, which means the edge router. And that is to say, every IP packet has a differentiated services header marked with a value and used by the router to control the traffic. If QoS is not configured in your network, what's going to happen, all the traffic will be sent with 0, which is the default value of DSCP, and the router will not implement any QoS. So in the past, before diff server, you would need to go to the router and explicitly dedicate and reserve bandwidth for each type of traffic, which caused the problem of scalability. Because when you go to the router and you set up, for example, 20 megabits for voice and 20 for video, if video traffic exceeds 20 megabits, it's like there's no other way to get more bandwidth. And with the diff serve or differentiated services, you do not need to explicitly reserve resources by application or type of traffic. It simply allows you to classify traffic flows using these values that the router uses to determine which traffic is more critical and which one is non-critical. And based on the diff serve standard, as I mentioned earlier, I believe there are 21 values, if I'm not wrong. And these values, they are used to mark the traffic. And as I said earlier, in VoIP, we are interested in 3 values, which are included in this slide. So usually when you go to the router or you go to the switch or any VoIP device and you go to TOS or DSCP or QoS, you're going to find some markings that starts with EF or AF or CS. And EF means expedited forwarding, and that's the highest priority. So when you go and you market traffic with EF, that means that's the highest priority traffic. And then there is the assured forwarding, that's for signaling, and it's usually used for SIP, because if the phone rings, half a second, that's not a problem. However, if you receive audio half a second, that's a problem because that's considered delay. And there's also the AF41, which is used for video. And the AF standards, they are classified in 3 different categories. And the ones used for video, we call it low probability drop, which means when you classify the traffic with AF41, you tell the router this traffic is not really important. It's not like the highest priority traffic. However, I want you to assure me that this traffic will be sent, and if there is any other traffic using a different DSP value, please make sure you prioritize this traffic. So these are the 3 values that we're going to be using in today's presentation, as well as today's live demo. So let me go ahead now and jump to the web interface of one of the phones so I can show you exactly where you can configure those settings. So I'm going to use one of the GXP phones. It's the 2170. So when you log into the phone and you want to set up the VLAN and the QoS, you usually go to advanced settings, and you're going to see some values here. The phones by default, they are configured with DSCP value 26 and 46. For RTP, we tell that the phone always sends the RTP traffic with EF, which means expedited forwarding, and the value of 46, which means this traffic is delay sensitive and it has to be prioritized over other traffic. However, one thing that you should know about DSCP is that it uses what we call the per hop behavior. In other words, when the phone sends the RTP to the UCM, it's going to send it to these values. However, if the UCM is not configured with anything and it's like DSCP is disabled, the UCM is going to remove this value and then it's going to send it with value 0. That's why I'm going to go to the UCM so I can show you how you can make the same thing on the UCM so that the UCM forwards the same value. So when the router receives the traffic, it's going to prioritize it. These are the values for the VLAN. So in case you have this phone on VLAN 20, you just enter the value 20. Talking about the layer 2 QoS, probably I didn't mention this during the presentation. Even layer 2 has a QoS, and we call it class of service. And class of service uses a value from 0 to 7. 7 is the highest priority, 0 is the lowest priority. However, you can't use 7 and you can't use 6 because 6 is used for different protocol, which is spanning tree. And spanning tree, as you know, it's a very important because if this protocol is not functioning normally, you're going to start having like some issues with looping in the network. That's why it is always recommended to not use value 7 or 6. 7 is, I believe it's used for networking protocols like EIGRP and stuff like that. But for VoIP, you can always use the value 5. So you can tell your switch, please prioritize this traffic at the layer 2. And one thing about the COS at the layer 2 is that this only works if you are using VLANs. Because if you're not using VLANs, that means the traffic from the phone or from the switch is not going to include the 802.1q header, and that's the header that sends this value. So if you're only using simple traffic like one network, flat network, no VLANs, nothing, this value is not going to help much because, as I mentioned, it's included in the 802.1q header of the IP packets. I mentioned earlier that all the phones, they have a LAN port and a PC port. In case you have a switch, like unmanaged switch, and you want to send, like, put the phone on VLAN 5 and the phone you want to put on VLAN 20 and the computer on VLAN 5. So what you need to do is just configure the VLAN 5. so that all the traffic that comes through port 5 will be sent on VLAN 5 instead of VLAN 20 or the default VLAN. For computer traffic, you always want to use a lower value than the voice traffic. You probably want to use 3 or 2. There's also the what is it called, the LLDP or CDP. This protocol actually, it's always recommended to have these options enabled on the phone as well as on the switch, because if you have it enabled on the phone and not enabled on the switch, it's like it's not going to work. So you have to have them both enabled at the switch level and at the phone level. And just to explain what LLDP is, it's a protocol used by the phone to advertise its capabilities to the switch, I would say. And it can be very useful when troubleshooting Ethernet connection, because reading the LLDP message can help you detect issues with speed, duplex, mismatch, or misconfigured IP address. Sometimes also when the phone reboots, they can send the VLAN ID in the LLDP message so that the switch knows that this phone is requesting an IP from VLAN 20, for example. CDP is the same thing as LLDP. They serve the same purpose. They basically carry the same function. And the main difference between the two is that LLDP is an open standard supported by many third-party devices, while CDP is a Cisco proprietary protocol. And I believe CDP stands for Cisco Discovery Protocol, if I'm not mistaken. So now that we configured VLANs and QoS on the IP phones, the next option is go to the UCM so we can make the same changes. So I'm going to log into the UCM, and then if you go to PBX, SIP settings, I believe is TOS, type of service, you will notice that TOS is disabled by default on the UCM. So all the traffic that the UCM sends will send it with the default value of 0. So what we need to do is make sure we use the AF. I can go back to the slide so you can. So remember here, signaling we use AF31, for audio we use EF, and then for video we use 41. So let's go back to the UCM. So for SIP, I'm going to use AF31. For RTP, I need EF, expedited forwarding, because audio is very sensitive to delay. And for RTP video, I'm going to use AF41, then save and apply these changes. This might require a reboot. So once you make these changes, just make sure you reboot the UCM. The next thing, you can also configure those values from the router. And I'm going to go to the router quickly, so I'm going to show you how you can do that. For this demo, I'll be using the Grandstream GWN, but I believe that most enterprise routers, they have this functionality of using QoS. So if we go to router QoS, one of the things is that I'm using 1.1, so make sure you configure this one and you enable QoS for upstream and downstream traffic, and then you specify your bandwidth provided by the carrier and choose the type legacy. Also make sure you enable QoS save. This will require a reboot, so you just reboot the router. And the configuration that we're going to be doing is under the legacy QoS. And if you look at my configuration, you will see that there are already some QoS configuration done on the router. Let me open one of them. So this is for video conferencing. I gave it a priority of 3. Priority on GWN is from 0 to 64. The lower the value, the higher the priority, which means if I put 1, 1 has a higher priority than 3. And the interface where we're going to be using QoS is 1.1, and the upstream that I want to dedicate to video conferencing is 20 megabits. So now let's talk about the bandwidth dedicated to these traffic types. So when I go to GWN and then I tell it, hey, please dedicate 20 megabits for upstream for video conferencing, and then when I go to the traffic filter, I'm going to specify what these the source of this video traffic. But I want to explain this before I go to the traffic filter. So when you put 20 megabits, it does not mean that that's the maximum that the video conferencing is going to be using. And that's why we call it differentiated services, because the value can differentiate. So when you tell the router 20 megabits for video conferencing, you just tell the router, please make sure you guarantee that the video conferencing at least gets 20 bits when there is a congestion. If, for example, video conferencing devices, they need more than 20 megabits and nobody's using voice, like the upstream bandwidth dedicated to voice, the router will automatically start using the using bandwidth from the 40 megabits of the voice. And then you have the priority. The priority, I'm going to give you an example how it works. So let's say let's give you this example. So let's say voice traffic, no one is using the voice traffic, so the 40 megabits is there and nobody is using it. However, in the conferencing VLAN and the door system, they both need more than 10 megabits and 20 megabits. So let's say both of them, they need 40 megabits more. Let's say you have many door systems in your environment. So the system or the router will automatically get the bandwidth from the voice VLAN and assign it to these two. However, the criteria that it's going to use to decide how much bandwidth to assign to each one is decided by the priority value that you set. So in our case, the video conferencing is using 3. That means it has a higher priority and it will get more bandwidth from the voice bandwidth that is not being used compared to the door system. So when you go to traffic filter, this is where you set up, you define the traffic basically. So let's say I'm going to use the voice traffic, and this is the traffic coming from the UCM, and I would like to assign this traffic high priority, which is going to be 46 expedited. The source IP, my UCM's IP is using this IP, this local IP, 172.16.0.100. I'm not going to specify ports or anything. The reason why I'm not going to include ports, because the RTP port is unpredictable on the UCM. It uses a range from 10,000 to 20,000, so you never know which port it's going to use. So I'm just going to leave the traffic marked based on the IP address, and the UCM is located in the voice VLAN. So I'm going to save and apply the changes, and now we have my QoS for upstream enabled. If you want to do QoS for downstream, that's when you need to go to policy. It basically works the same way we did with the upstream. We can call this one like voice, and the traffic is coming from WAN 1. Priority, we're going to give it 5, and the rate, we're going to give it 40 megabits, and DSCP 46. We don't want to use any source IP, but I want to use the IP destination, which is going to be the IP address, the local IP address of the UCM located in the voice VLAN. Save and apply. So I'm going to use 4. So that's it for QoS, and this is how you configure QoS. So every time the router, if there is a congestion, it's going to use the DSCP value to decide which traffic to prioritize over the other traffic. So let's go back to our slides. So the next topic is going to be about bandwidth. This is a very popular question. A lot of people, they ask all the time, how much bandwidth do I need for my VoIP calls? For audio, so I have two numbers in here, one for audio and the other one for video. So first of all, let's start with audio, or this one to, sorry, go back here. The numbers to the right. The amount of bandwidth required for audio is usually dictated by which codec you're going to be using. If you are using a low bit compressed codec, that's going to use less bandwidth, but it's going to take a lot of CPU resources from your device. If you are using G711, which uses approximately like 64 kilobits rates, but it's less, I would say, less resource intensive, this is how much bandwidth it's going to use. So let's chunk it into numbers so you understand how I came up with this number. When you talk on audio and you send the audio in analog signal to the phone is going to take every 1 second of audio, analog signal, and then it's going to chunk it into 50 pieces of audio, and each piece of audio will carry 20 milliseconds of audio. Then it's going to take that 20 milliseconds, encode it using G711, and then send it as a packet. And when it sends it as a packet, it needs to add headers to it so that it can be forwarded over the network. So for each RTP packet, the payload is 160 bytes. If we add the RTP header, it's 12 bytes, plus the UDP, because RTP runs on UDP, so it's 8 more bytes. And the IPv4 header, it's 20 bytes. For the Ethernet theme, it's a 14 bytes. In case you are using VLANs, you need to add 4 more bytes. So a traffic with VLAN or frame with VLAN, usually it's 218 bytes. Without VLAN, it's 214 bytes. Time, 15 packets per second, gives us this number, which is 85.16 kilobits per second. That's how much bandwidth is used by an audio traffic. But this doesn't mean that you need to be strictly dedicating 85. Usually you should add 20% more, I would say like 100 kilobits. The reason why, because there's the RTCP traffic, there's some overhead going on, like the SIP traffic, subscription, notify, and all that kind of information. So you want to take that extra traffic into consideration. When talking about video, things are a little bit more complicated. It's not as simple as the audio. A lot of things are involved in deciding how much bandwidth you're going to be using. For example, if you use JPEG eats up a lot of bandwidth, more bandwidth than the H.264. The resolution also is a criteria to decide how much bandwidth. The video quality, when you go to the profile and you select high, medium, or low. The frame size, how much frames you're going to be sending. And the frame per second. 15, 60, or 30 or 60. So I put some numbers in there, just approximate bandwidth and how much it's gonna take. For example, if you want high resolution with 1080 pixel with a medium video quality and 34 frame size and 30, like you're looking for HD quality, that eats up to 8.5 megabits per second. All right, so that brings us to the second topic of today's webinar, which is the SIP settings on the UCM and the IP phone. So when deploying an IP phone behind NAT or an IP PBX, we are usually confronted with some issues that you will run across, especially related to NATing. And since private IP addresses are not routable on the public network, we usually use NAT to fix this by translating the private source IP with a public IP address, which is routable on the public network. However, this usually creates an issue, especially with audio. And because the IP-PBX by default is not aware, because if you put the UCM behind the router, it's not going to know what is the public IP address unless it uses some other mechanisms. And it will automatically communicate it's a private IP address in the message body of the SIP messages, because NAT only changes the source IP address of the IP packet. And I mean by that the IP header. But the content of the SIP message does not change, including the connection information and the port number that the UCM communicates for RTP, which will be used to send and receive audio. So the IP-PBX and the IP phone exchange the path over which the audio traffic will travel in the connection information header. I provided 2 screenshots right there so you can see it. So if you take a look at it, in the SIP message sent by the UCM in the first example, you will notice that the UCM is actually asking the remote phone to send audio traffic to its private IP address 172.16.0.100 on port 16,628. And because the private IP address 192.16.0.100 of the UCM is not routable on the public network, the local router will just drop the audio traffic, and the users will have no audio in our example. And this behavior is very typical with remote extensions and when using soft phones or when you have some other devices paired with the UCM. So to correct this behavior, the UCM has a SIPNAT setting that allows you to configure it with the public IP address to use in the SIP message as illustrated in the screenshot that says with the SIPNAT, yes. So in a few moments I will show you how to configure the SIPNATs on the UCM to avoid that issue. But right now I just want you to get an idea about why do we use SIPNAT. The next SIP setting that I would talk about is the RTP Keep-alive. And before I explain that and also what this feature does, let's have a quick look at the call flow example in this slide. So the user or the caller initiates a call using his cell phone. The UCM receives the call and forwards it to an external number because inbound route is configured with the call forward. So the remote phone will ring and the caller will hear ring back tone, because so far we're just using SIP protocol. We're not using RTP yet. So when the remote phone actually answers the call and starts sending audio, and the router sitting in front of the UCM receives the audio, the router will block the traffic because there's no established connection from the UCM, because the UCM didn't send any RTP traffic to pinch a hole in the NAT table. Because remember that the UCM so far has only forwarded SIP packets. There's no RTP for audio, and that is normal for the firewall, or in case you just have a router, to block the incoming audio traffic, which causes both parties to have a call with no audio. And what makes matters worse is the fact that the port on which the audio traffic is sent is usually random. As I mentioned earlier, the UCM uses a port from the range 10,000 to 20,000, so it's always a random number that it can choose. And port forward, I would say, will not solve this issue, unfortunately. So to overcome this issue, the RTP Keep-alive can be configured to pinch holes on the NAT table, and this is how it works. So when you have RTP Keep-alive configured, let's say with value 1, the UCM will read the connection information for RTP in the SIP message of both parties, like the remote phone and the cell phone, and it will send an empty RTP packet to both the caller and the remote phone, which eventually opens these ports on the NAT table for incoming traffic, because the audio has to go through the UCM. So now let's go to the web interface of the UCM and show you how you can set that up. I'm going to go to the UCM. Give me 1 second. I'm just going to check. So we have some questions so far. Okay, it looks like everybody else can hear me. That's good. So I'm going to go to the PBX settings because this is where we do most of the SIP settings. Then I will specially go to NAT setting, this one right here. So assume my UCM is, if you look at the, let me show you here. So it makes sense when I, system network right here. You will notice that the UCM is actually behind the NAT, and I'm reaching out to the UCM from another router. So in our case, let's assume this is the public IP address of the UCM and the internal IP of the UCM is this one. So this is how we're going to configure it. You just go to SIP settings, NAT settings, and then you include the public IP address, which is 22.202. I'm using a private IP, but assume or just suppose this is a public IP address. The UCM, the voice VLAN of the UCM in which it is located is 172.16.0.1. So in case you have devices on multiple VLANs that talks to the UCM, so let's say you have the marketing VLAN and people over there, they have voice VLAN, voice phones or IP phones registered to the UCM, what you need to do is make sure you add the remote voice VLAN of the marketing people to the list. So everybody sitting behind the NAT, including as many VLANs as you have, make sure you include them in that list. Then save and apply the changes. This is going to require a reboot of the UCM, so I'm not going to apply these changes, but I hope that makes sense. So let's go to TOS so we can talk about the RTP Keep-alive. By default, this is set to 0 on the UCM. So if you want to avoid that issue with call being forwarded on the UCM and you have no audio, make sure you set that one to yes so that the UCM can pinch holes in the NAT table of the router to allow incoming traffic to the UCM and then back outside again. So that's where you configure RTP Keep-alive, and I suggest you use one packet per second is not a lot of traffic. There are also a couple of settings that I would like to talk about, which is the Trust Remote Party ID and Send Remote Party ID. By default, these two options, I believe they are disabled, so I just enabled them on my UCM. So I'm going to explain what these two options actually do on the UCM. If you have these two settings unchecked, this is what's going to happen. I call the UCM sends the call to the IP phone. The IP phone answers the call. You're going to see my caller ID. However, when you park my call and then another phone retrieves my call, what they're going to see is their extension number and the caller ID of the call park, which means they're going to see 701 or 702 based on which call park lots they're going to use. So that's the default behavior. If you want the UCM to keep the original caller ID when calls are transferred, forwarded, or retrieved from call park, that's when you need to make sure that these two settings are checked. And this is how it works. The UCM sends the call, you pick up, you're going to see my caller ID, you park the call, the call is sent back to the UCM to park it, then another extension dials 701, for example, to retrieve the call. So when they retrieve the call, the UCM sends another invite, but this time it includes the remote party ID or the remote caller ID, depending on how you want to call it. And then the UCM, when it receives that message, it's going to display the original caller ID. So you don't have issues with keeping up the original caller ID of the initial calls. All right, so the next thing I want to talk about is, let's go back to the slide so we can see what we have here. Yes, so we're going to talk about NAT traversal. This setting is very useful when using IP phones, especially IP phones. And these settings are useful in this context when you have the IP phone behind NAT and the SIP server or the Voip provider or the hosted PBX is on the public network. Of course, in this situation, you are going to have some NATing issues. A lot of people, they overcome this issue by enabling port forwarding on the router. That helps, but you don't want to go and configure port forwarding for each phone. So these are some mechanisms that you can enable on the phone to help you with the NAT issue. So among the NAT traversal mechanisms supported on the IP phones, the first one is Keep-alive, which remains the first option to try when the IP phone is behind NAT, because it's very easy and the way it works is very simple. So you just go to the phone and you set NAT traversal to Keep-alive. And when you do that, you essentially tell the IP phone to keep sending UDP packets, empty UDP packets, to the IP address of the SIP server. And when this traffic goes through the router, the NAT binding will remain open, which means if your router is doing changing the port number and you keep sending that that information, the router is going to keep that hole open on the router, so incoming traffic will not be blocked. And this issue solves these mechanisms solve one main issue, which is issues with incoming calls. Sometimes the customers will tell you, hey, after when I wake up in the morning, I'm able to call out, but if someone calls me before I call out, it doesn't work. The reason why, because when you make a call from the phone to outside, you actually open the hole in the router. That's why it starts working. But in the morning, when after like 6 hours, 8 hours not using the phone, or just an hour, which is the registration time out of the phone, the router is going to close that that NAT binding on the router. So when incoming traffic comes on port 5060, the router is going to tell the incoming traffic, I don't have any traffic initiated from inside for that specific port, so I'm just going to block it. The second mechanism that you can enable on the UCM, on the IP phone, I'm sorry, is the stun. The stun allows IP phones behind a router to learn their public IP address, and the IP address changes its local IP address with the learn IP address and sends it in the SIP message when it tries to establish the call. It's like when it sends the invite, it's going to include the public IP address in the SIP message. And stun configuration is often recommended when the SIP server uses direct media. In other words, instead of sending the audio traffic to the SIP server and the SIP server forwards it to the destination, like in the case with the Grandstream UCM, some Voip providers and hosted PBX, they use the IP address and the port number in the connection information received from the SIP endpoint and provide that information to each device so that they can talk to each other directly without sending the audio through the IP PBX. And this is, I believe it's well illustrated in this call flow that we have in the slide. The third mechanism we have is UPnP, or basically it means Universal Plug and Play Protocol. Is also a useful feature that allows the phone to find out the external IP address and have the router configure itself with port forward. So for security reasons, UPnP on most routers is disabled by default. So you're going to have to go to the router and make sure that it supports UPnP before you check this option, and also test it to make sure that it's working efficiently, because a lot of routers, they claim to support UPnP, but they support it for the basic functionality of detecting devices, but they don't support the option to configure port forwarding automatically on the router. So this is something that you want to check with the router vendor or read their user manual. As for VPN, which is the last one, you select this option only when you have the IP phone configured with the OpenVPN. So I'm going to show you where you configure these options. So I'm going to use not this one. Close. So let me open the 192. Okay, so I have a 2170 that I'm going to use for the demo. So this is where you configure the NAT traversal. Looks like I'm having an issue. Let me go back to 2170. Just bear with me 1 second. I'm trying to figure out what's going on here. Okay. So when you go to the GXP phone and you go to account setting and you choose the account, you go to network setting. This is where you configure the NAT traversal. And these are the options that you have: stun, keep alive, UPnP, auto, and VPN. As I mentioned, you always want to go with keep alive first because it's very easy to implement. It doesn't require you go into the router and make changes and all that stuff. So set it to keep alive. And then you go to settings, I believe general settings, if I'm not mistaken. That's where you configure stun server in case you want to use the stun server with direct media, as I mentioned earlier. The Grandstream, we do have a stun server, and I believe it's stun IP video talk.grandstream.com. I think I have a trace here. I'm not. Yes, right here. Filter the traffic with stun. So this is how stun works. So I have a good thing I have a trace here. This one is sent by the UCM because the UCM also has this option to configure stun. So this is how it works. The SIP endpoint behind the router, it's going to send a binding request asking the stun server, hey, what's my public IP address? Then the stun server will reply back with this information. It's going to tell, hey, your mapped address, your public IP address is 50.227.2. This is the public IP address of my lab. And then it gives you that information so you would know your public. So the UCM, when it receives that information, it's going to use this public IP address to send it in a SIP messages when talking to devices outside the network. So let me go back here. See what's next. WebRTC. So WebRTC now it's supported on the UCM, and I'm going to show you. I'm going to do a quick live demo for it. Just a few information about WebRTC. It works with the Firefox, the latest versions, and Chrome as well. It supports up to 4 video feeds in the UCM. One of them is 1080, and the others, they should be in QVGA. It supports up to 100, which means you can have up to 100 users connected to the WebRTC. And I believe with the beta firmware, which is 19.27, this number will be increased to, I believe, to 200 because they made some adjustments to increase the number of people who could log into the WebRTC of the UCM. And during a video conferencing, so when you schedule a video conference and you use the WebRTC to make video calls from the UCM, the 80200 supports 8 participants, and the 6500 supports 15 participants. And they do support the option to do blind transfer and also attended transfer. And one of the added features to WebRTC, I believe in the latest firmware, is email notification and the chat. So now if you initiate a call from WebRTC to the Grandstream UCM video conference, now you have the option to initiate chats in a video conference. There's also an email notification. So in case you schedule the video conference on the UCM is going to send you an email notification. The same thing that works with IP video talk. So let me go to oh boy. So I'm not going to log back here yet. So these are the things that you need to do for WebRTC to work. The first thing is make sure that WebRTC is checked on the UCM. By default, it is checked, so you don't have to worry about that unless you make a change. The other thing, when you create extensions and you want them to use WebRTC, by default, WebRTC also is enabled at the extension level. If you have an extension for a user and you don't want them to use WebRTC, you can always come here under features of the extension and uncheck the WebRTC. One more thing, yes. So now you have extensions created, you have WebRTC enabled. So how are the users going to log to WebRTC from their computers? First of all, each user, you will assign them their own extensions. For example, if 1001 is being used by Steve, you're going to tell Steve the username is going to be 1001. And then the password associated with the login for extension 101, that's the one that you configure under this option. So I'm just going to go ahead and configure a password for the user. Save and apply the changes. So I'm going to use Chrome to log into, let me log out, exit. Let me show you first how you log into Grandstream. So basically, you're going to use the same IP address as the UCM. So when you put the IP address, it's going to take you to the login page of the UCM. Then you want to click on Grandstream Wave. And that's going to take you to the WebRTC. I'm going to use extension 1002, put the password, then log in. It's going to ask you to confirm the microphone, the video, hi everyone. Then just click OK. And then from here, you can start calling numbers. So this is the WebRTC interface that you can use from your computer to make and initiate calls. You have the dial pad right here to dial extensions, or you can dial external numbers, or you can use the contacts. So let's say, for example, you want to call extension 106. Just ring the phone. Once the remote phone answers the call, then you can start have two-way audio, and you can do screen share as well. Let me call a different number and see which one of them is going to pick up the call. Let's try 105. Let's use 105. So as you see, I'm calling extension 105 because it has auto answer. So the remote party has to confirm. I believe the phone has the option to confirm the video call. So if I am close to the phone, I can just enable video. Then I'm going to have two-way video call. Then from here, you have some other options that you can configure from the WebRTC, and one of them is the screenshot. So let's say you have a presentation that you want to share with some users. You just go to WebRTC and then you choose which option you want to share. You can share the web page like a tab, or you can share the whole screen, or you can share a specific application. Especially when using PowerPoint, you want to use the application. Then you go ahead and you choose the PowerPoint application. There's also the option to transfer calls to other extensions or other WebRTC clients, plus mute and hold. I want to try something else. I'm going to go to the UCM here and look for the video conference extension. I believe I have one created, 6300. So from WebRTC, I'm going to try to call 6300. Let's see what's going to happen. I believe it's 2018. Join the conference. Okay, so you can create video conference on the UCM, and then you can call into the conference room from the WebRTC of the UCM, and you have some options, some very nice options that you can use right here. And one of them, I should have another phone call. So one of the options is like IP video talk. You can see who is in the conference call, and you can also use the option of chat. So you can send your messages in the WebRTC chat, and you can chat with people during the conference call. So those of you who are familiar with the IP video talk, WebRTC on the UCM uses the same concept, the same design. You can also change the layout in case you have multiple people joining the conference. You can change the layout. You can share your screen with the users. By the way, when you want to use the share screen, make sure you install the plugin. It's a quick install. That shouldn't be hard. So that's it for WebRTC. What is the next topic? The major enhancements on the Grandstream firmware version 1.0.19.21. So I'm going to spend another probably 5 to 10 minutes to finish the presentation so we can have plenty of time for the Q&A section. So the major enhancements on the UCM 1921 is we added support for TLS version 1.2. We increased the concurrent calls on the 62 and 6204 to 50 and 75 respectively. We added the chat functionality to Grandstream Wave, the one that I just showed you. We also added support for a secure LDAP on the UCM in case you want to use it for security, in case you have a secure LDAP. Now we have the option also scheduled announcement paging, which means you can schedule a paging instead of you going to the phone and dial the paging code. We also added the ability to monitor and change inbound mode for individual routes. I'm gonna go through some of these options from the web UI. We also added the search function to the web UI of the UCM. So in case you are looking for a feature and you don't know where it is, you can just use that option. We added support for API with PMS. You can also now you can select the ring group for operator during a voicemail prompt. We added an option to customize privileges for user to monitor and configure only zero config, which is a very nice feature. A lot of people were requesting that one. We also added the option to upload OpenVPN configuration file to the UCM, and we also added auto record option to the UCM. So let's go through some of these options. So this is the option, the search option. Let's say you are trying to configure the wake up service and you don't know where this option is. You just click on it, then it gives you some options. So you can choose from here which configuration page you want to use to configure the wake up service. So this is the search option that we added to the UCM. The next one that I want to talk about is the inbound routes. Some of you know before multi-mode in the UCM applies to all the inbound routes, which means if you go to the UCM and you dial *61, it's going to change all the inbound routes to the default mode, and if you dial *62, it's going to change all the inbound routes back to mode 1. Now with the new firmware, you can actually change the mode for each route without the need to do the changes for the whole inbound routes. So this is how it works. So when you go to the inbound routes and you have inbound multiple mode configured, make sure you check this one that says enable route level inbound mode, and then you're going to assign it an inbound mode suffix. Just make sure you choose a number that is not being used on the UCM. Any number, it doesn't matter. And then if you forget how to use it, you can always hover over the tooltip, then it's going to tell you exactly how to switch between the two modes, which means you're going to use the global inbound mode feature code *61 and *62 plus this suffix, whatever you configure here, so you can switch between the two modes. There's also even a better way to do it. So let's say I have 99 configured here. Now you have the option to monitor which mode is being used on the UCM. So I'm going to configure, let's reset these. So let's say you want to monitor this inbound route right here, and you assign it a suffix of 99. You just go to the IP phone. I can choose VMPK6, choose the mode BLF, account 1. and I can, for example, call it inbound route 1, for example. And then the value, you just enter the 99, the suffix that you configured under the inbound. Save and apply changes. So once you save and apply changes, the BLF is going to turn green if default mode is enabled. Just by pressing the BLF button, it's going to switch the inbound route to mode 1, then it's going to turn red. So this way you would be able to monitor which inbound route is being used. The second option that we added to the paging is announcement paging. It's like a combination of the announcement center that we have and the paging functionality. So I'm going to enable this one. You assign it a name. You can use any example. For example, this is like a wake-up call for the people in the warehouse. You can just choose this mode, then you can upload any file. You can upload a music file so that at that specific time it's going to play that music. Choose the time, and then you can tell the UCM whether to repeat this paging every week, every day, or every month, depending on how. And then you have the option, do you want to use unicast or just multicast? So it's up to you. That depends on your network and how you want to use each one of them. Then you can choose the extensions that you would like them to be a member of that same paging group. So before I jump to the troubleshooting tools, I'm just going to go through some Q&As here, just to make sure at least I answered some of them. So Virgilio Familiale is asking this question. This is the information from the ISP. Oh, okay, so there is a question before that. Let's do that one later. It looks like you have four questions for one issue. Jonathan is asking, RTP keep alive in seconds? Yes. So when you enter 1, that means every second. If you want to do it every 2 seconds, just enter the value 2. David Rostoker, how are you doing, David? He's asking, if I used inbound mode with multiple suffixes, like different inbound routes, is there a single feature code that I can use to turn all the inbound routes, all suffixes to mode 1? As I mentioned right here, let me go back here. Inbound mode. So when you use *61 or *62 without any suffix, you're basically changing all the inbound routes. If you use it with a suffix, you change only the inbound route using that specific suffix. I hope that answers your question, David. Jonathan is asking, is video call recorded and available online? I believe you're talking about the WebRTC, Jonathan. Please correct me if I'm wrong. Oh, you're referring to the webinar. Yes, the webinar will be available at the end of I'm going to send it before the end of today, so you can have the link and you can watch it and comment about it. And one thing also that I want to mention, the next quarter we're going to send a survey. Again, Grandstream is going to send a survey. If you want to participate and if you have a topic that you would like us to talk about, please make sure you participate in the survey. If you don't get the email about the survey, you can always go to the YouTube video, the one that I'm going to post later today, and then you can add your comment to it, asking about the topic that you feel like you want us to talk about it. Nino is asking, when will you allow end users to record their own custom recordings without being an administrator? I believe you're referring to the IVR. So I'm going to go back here because I'm running the beta version. I want to see what privilege levels they added. Extensions IVR. I still don't see the custom prompt recording for end users. So probably, Nino, this is something probably that I'm going to push for again and see hopefully if they can implement it in one of the next firmware version. Hi, Atsushi. Atsushi is asking how many concurrent video meeting is available. Atsushi, if you are using the UCM, the video conference on the UCM, I would suggest you stick to one video conference call on the UCM. If you have a need to have more than one video conference, you can always try the Grandstream ipvideotalk.com cloud service. It comes with a free plan that you can try for I believe for a few months or something, and then you can play with it. And then if you want to increase the number of participants and the video streams, then you can go for an enterprise plan. So I'm going to go to Virgilio Familial. He's asking, hello, I'm from Saudi Arabia and have a problem in Voip trunk. I open a ticket and technical support assigned already access our UCM, but until now for more than 1 month, problem is not yet solved. I have already some clients using Grandstream using analog trunks, and this is my first time to SIP trunk. Our company is involved in network and security systems installation. Our system really disappointed about the situation. Customer, you know what, Virgilio, at the end of this webinar, you are going to receive a thank you email, which includes my email address, okay? Just send me that information to my email so I can look into it, because I see there is a lot of information that you included in the Q&A section, and probably you want to send me an email so we can work on it together. David is asking, will Grandstream provide for read-only access as a part of? Oh, that would be nice to have. Yeah. So David, that could be a feature request for the dev team. I'm pretty sure now we don't have this option, but it's very, very nice option. Yeah, thank you for bringing that up. How many one video call is available currently? So let me go back to the spreadsheet here, not spreadsheet, the slide, so I can show you these numbers. So if you are using 6200, the number of participants is 8. If you are using 6510, the number of participants can go up to 15. I hope that answers your question, Atsushi. So Nino is asking again, we would like clients to be able to change their own recorded messages for scheduled IVR events, Christmas. Yeah, I saw that they added for the IVR, so they can only change the IVR. I'm gonna check with the engineer and see if there is a way they can add like recording those prompts just using a custom privilege. Taylor is asking, I would like to be able to upload user voicemail prompts the same way we can upload system prompts. I believe there is that option already, and it's been there for quite some time. So let me go back to call features, voicemail. So this is for you, Taylor. There is an option where you can upload those voicemail custom prompts from the UCM. You just go here to username prompt, click on it, then create a custom prompt, then you use the same extension to add the voicemail prompt. I believe there is a document. If you go to, let me go back to Grandstream again. If you go to the Grandstream website under the documentation, you will find a document that explains to you exactly how you can upload those voicemail prompts. It's probably in the administration manual. Just go there and then it's going to give you instructions how to configure that one. But again, this is where you configure those prompts for the users. Greg is asking, semi-off topic status of iOS GS Wave still not usable, goes to sleep. I believe I heard someone talking about this, but unfortunately I don't have any updates yet. I'll probably want to use my email and check back with me at a later time about this, Greg. And John is asking, on the WebRTC slide, it says up to 4 video feeds in a conference call, but it also says 8 participants for UCM. Yeah, John, that's different, which means when you have 8 participants, you can have 4 participants doing video feeds and 4 just using audio, which means 4 of them can share their video, and you can include 4 other SIP endpoints like an IP phone calling into the conference, and also just having audio without sending video feeds. That's what I mean by that information in the slide. NII is asking, my email notification does not work on my UCM. Can you be more specific about notification about what exactly? If you can, please. All right, so I still have 10 more minutes. I'm just want to go through the troubleshooting tools available on the UCM. So we're going to go to maintenance, and let me first talk about what do you need usually, which logs do you need for each issue. So in case you are experiencing SIP stack related issues, let's say you make calls, there's no audio, or the call drops after a few minutes, or there's audio choppiness on the SIP trunk, or information like that, that's when you need to network troubleshooting. And you can use the Ethernet capture. It's very simple. Just choose the Ethernet capture and use whichever interface you are using. Let's say, for example, if you're using the UCM in a route mode and you have WAN and LAN, if the issue for incoming calls from the carrier side, you want to use the WAN side. If it's in switch mode, you're always going to have the option to use LAN. So if that is the case, just start the trace and then try to replicate the issue. If the call is dropping after 32 seconds, start the trace, make a call, and wait for 30 seconds. Once it dropped, then come back here, stop the trace, download it, and then you send it to the Grandstream support for someone to analyze it. If you have issues related to the system, so let's say the system is crashing, or you have issues with the analog lines, like people, they call you on the analog, and then you get like some static or some buzziness or some issues like this, and you want to take traces, you can use the syslog server, because the syslog provides logs that are not provided in the packets capture. You don't need to have a syslog. So basically, let's say the gateway IP address of my UCM is 192.16.0.1. I'm just going to put the IP address in there, and then based on the issue, the type of issue that you have. So let's say you have issues with the CDR API, and it's not working for you, and you want to do some troubleshooting, just go here and check this option. If you have issues, let's say with the with zero config, just go back here and then select the zero config logs. If you have an HA like HA100 and you notice that there are issues and you want to troubleshoot them, check this box, and then you can go back here. Usually we're going to recommend to you which options you need to enable on the syslog. But my point is, you don't need to have a syslog server to run to take logs from the UCM. Just enter the IP address of your gateway, save and apply, and then you go back to the network troubleshooting, and then you start the trace. Then the UCM is going to capture both the network traffic and the syslog that the UCM sends to the gateway. This way you will have all the information in one trace. There are other tools that you can use on the UCM, and one of them is the PRI signaling trace, in case you have a PRI and you notice issues like caller ID doesn't show up, and the PRI provider, they said, oh, we send the caller ID. So for that type of issues, that's where you need to run the PRI signaling trace. There's also the analog record trace. If someone, for example, reports that calls through the analog lines are so low, or they come with the static and you don't know, is it the line, is it the UCM, or is it the phone? You can always take an analog record trace, start two-way or one-way, then select the channel that you would like to take the trace from. If it's FXO, FXS, start the trace. When done, you're going to get two files in a raw format. So these files, you need some software tools so you can play them, so you can hear whether the audio came with that issue, or like the audio came on the FXO port clear, and then but when the phone receives it, it has some choppiness. So that type of troubleshooting just helps you pinpoint the source of issues, so you would know where to go and focus your troubleshooting. So just start, as I mentioned, and then stop. You're going to get a raw format. I use Audacity. It's an application that you can also download for free from the internet, and you can use that one to play raw format audio files. If it's an issue with a PRI, you can also do the same thing as with the analog, start and play, and then it's going to give you a call recording that you can use to play, and then you can see how you can detect the issue. So I believe we have covered. We only have a few more minutes. If you guys have any questions, we still have 1 more minute to go over it, and otherwise we can just end this webinar. So anyway, I'm here. I'm just going to wait for another minute just in case you have some other questions. So I don't see any more questions. Again, thank you everyone for being here with us today. This webinar will be uploaded to our Grandstream YouTube channel, and then I'm going to send you the link for it before the end of today, so you can have a look at it and then watch it again. And thank you very much, and have a wonderful day.